So much for me. Yeah. So good evening, everyone, once again.
Good evening.
Evie, have you started recording?
Yes, please.
Great. Before I start, can you all see my screen? Let me know.
Yes, I
Yes, we
can.
can see your screen.
Yes, we can.
Yeah. Fantastic. So good evening once again. I still remain Yemi Ayola, and I'll still be taking you on manual testing, software introduction to software testing generally. So please, the rule is if you can't see my screen, please just mute yourself and let me know so that I'm not just going without us not seeing the screen. So today is still introduction to software testing, mainly manual testing. And before I start the class for today, I'll just quickly do a recap on what we did last week, and let me see if we still have people, if you guys can still remember, and then we can start with that. So the first thing I did last week was to mainly do an introduction into going into the background of software testing, what exactly it entails to test. I brought what I was giving you was more of a real life scenario and also bringing you back to the software world so that we can understand it from both ends. I gave example of cooking food. I gave different example using pen, having to balance your water. Those were examples we were given on the background. And my major scenario for that day was using a car when you go to a showroom. Then you want to buy a car. The first thing is that you go to the showroom, you look at the car you want to buy, you will what your expectations are, what you like to see in the car. So those were the things I explained on Wednesday precisely. So also I moved further to explaining to you what the skills needed by software tester, a manual tester, which I explained the the software skills that you need to have. Major one is testing skill. You still need system, you need SQL, you need automation, you need knowledge. The major knowledge that you need here is testing knowledge, which I said predominantly we all do have. Likewise, also, I move further to explaining to you different roles when it comes to software testing. What are these different roles? First of all, I explain to you what type of name that is called by we as manual tester, we as software tester, name or roles attached to our name. I mentioned quality assurance engineer. I mentioned a QA test analyst, functional tester. We're talking about UAT tester, user acceptance tester. Talked about a test analyst. Talked about manual tester, software test analyst. Kind of a lot of names there that are stick to that role. After then, I did show you what the salary expectations were, how juicy it were, and if you I gave you a random of picked a graph from 2006 to 2023. That was what I showed you on the graph. Likewise, after I have done the salary expectation for we as software testers, QA tester, I also moved ahead to now tell you what is the quality of a good tester. You must have good verbal and written communication. You must have the passion, analytic, technical. So you must be productive. These are skills that have it. You must have good eyes for details. You have listening ear. You must pay attention. You must think out of the box. Those are quality of a good tester. Furthermore, I now take you through what is testing. Testing, I explained to you. Testing is for us to know whether a functionality, a feature, a software, an application is working as expected. That is what the meaning of testing, which I said, what can be tested. So two things that can be tested: hardware, software. Hardware, things you can see; software, things that cannot be seen. Which example I gave, like the way internet browser, talk about games. So those were it. And also I said, what types of testing do we have? Manual and automated testing. Currently, you're in the manual class. After this class, it's going to go to automation. After then, I moved further to explaining about the software testing generally. I said it's not complex. It's just testing to ensure that an application is working as expected. Those are things that I explained. And also I said software testing is a discipline, it's a role. So that's it. I also moved ahead to say, what are the consequences if we don't test properly? And the consequences could be loss of business reputation, injury, death, loss of money. All these were examples that I gave regarding consequences of software testing. Then that takes me furthermore to say, I mentioned two things. I move further to say um, the three brothers, which I talked about: error, failure, defect. They are three in one. So error is human mistake. Defect is the inconsistency between expected and actual result. Don't forget those two words. I mentioned that you should keep it, and we are still going to talk, which I explained: actual and expected. Expected is what you're expecting. Actual is what you're actually seeing when you're testing. Likewise, I mentioned failure is the consequences of defects. So that's it. Of course, examples of errors that I said, it could be anybody within a team, which it could be the business analyst, it could be the customer, it could be you and I. It could be anyone within the team that can cause the error. It might not just be the code only, it could be anyone. Likewise, also, I moved further to say, um, we now talked about the general principles of testing. I said there were seven, which we said exhaustive testing is impossible. We talked about the early testing. We talked about testing shows the presence of bug. We talked about defect clustering. We talked about absence of error fallacy. So those were part of the ones we talked. And furthermore, I moved to the fundamental test process, which there were five: test planning and control, test analysis and design, test implementation and execution, evaluating exit criteria and reporting, test closure report. I did explain all this in details. Likewise, the final phase was just the psychology of testing, to just tell you various people can be drafted to do testing. So that leads us to, that was just a recap of what we did last week. But today is going to be another extensive method. This is the chapter 2 of the textbook that we have. But it's not going to take us to how we are going to work as a team, how things are done, what are the processes that we do. So those are the things I'm going to teach you today. So that takes me to my learning objective today. What are we going to learn today? The first phase of our learning today, we are talking about software development life cycle. We call it SDLC, software development life cycle. Also, we're going to talk about different models of SDLC, that's software development lifecycle. I might just be mentioning SDLC. Please have it at the back of the, it's an acronym. The acronym of it is just software development lifecycle. That's the meaning. Pros and cons, that's the advantages and disadvantages. Then concepts of learning, of understanding it. So I'm just going to bring you the concept of understanding all this. This is the first phase of it. Then I'm still going to do the next phase, which is part of this together, which is going to be testing. We as testers, what we need to know. So let's go further for today. Software development life cycle. So it's called the iterative and incremental development model. So these are various types of software development lifecycle. We have the rational unified process, we have the spiral, we have V-model, we have Scrum, we have Kanban, we have waterfall and V-model again. Then we have the last bit of it. So all those ones I've mentioned initially are just everything generally. Are examples. That's what I mean is these ones, these, all these I've mentioned. Rational unified process, spiral, V model, Scrum, Kanban, talk about the V model and also the waterfall. Then the three major ones that we do, that we use, that are used mainly waterfall, which is the linear model, V model, which is the sequential development model, and we have the iterative incremental development model, which is agile. Don't forget, currently you'll be working in an agile environment. You see this guy, this person here, is what is the odd every role now is trying to imbibe this, to implement, adopt this person. Though we still work on this side, but everyone is going here, and you know the reason shortly. You're going to know the reason for this shortly. But have it in mind. 3, waterfall, linear model. You'll see the reason why I said so. V model is the sequential development model, and I've got the iterative, which is the incremental development model. These 3. So that takes me to each of them. But before I start, I'm going to start with explaining what software development lifecycle is. What is software development lifecycle? Is, as I've told you, that we call it SDLC for short, and is called software development lifecycle. Is the process that produces software with the highest quality and lowest cost in shortest time possible. Now, let me just explain this line to you. Highest quality, take it, this part, and lowest cost. The reason why this is that with SDLC, you do things in bits. Let's take an example. I will go back to the background of testing that we did initially. Let's take the literal one. I'm going to take you to the world and I'll bring you back to the software. So I'll take you to real world so that you can understand. Then I'll bring you back to software testing. So let's take example. We cooked rice last week. So the same rice, I'm going to cook it. But how it works is that for you to get high quality, is that the first thing is we know all the ingredients that we want to use to cook this rice. Every equipment, ingredient, what is needed. Salt. These are examples of what we need. We know that at the back of our mind. But how we actually want to achieve it at lower cost is that the first thing we want to do is that what is the first thing we need here if we want to cook rice? That is the next Everybody will agree. Is this the water we want to use? Yes, it's the water we want to use. Then let's take it again to the next one. What is the next thing that we need? The next thing that we need is that we need a pot. We need a pot. Okay, yes, we want a deep pot because so that it will be big pot. This is what we want to use to cook the rice. Everyone agree? Okay, the developer, the solution architect, everybody, tester. Yes, this is the pot we want to use. Fantastic. Okay, we have the pot now. We'll keep the pot. Don't forget, we kept the water somewhere. We are keeping the cup, the pot too, somewhere. So we have two things out of it, which we've agreed, but we've not started using it. The next thing we need, oh, we need raw rice. We quickly look for raw rice. Oh, what type of rice we want? Is it basmati? Is it long rice? Is it easy cook? We select the one we have. So we put various. Oh, this is the one that we want to use according to the requirement that we are given. We want basmati rice. We take basmati. We put it one side. That's the third ingredient. Oh, what is going to make this thing work? Oh, we need a cooker. Is it electric cooker we want, or we want a burner? What eggs? Oh, we want an electric cooker. Fantastic. That's the fourth one that we have put there. So, in a nutshell, what we are trying to do is that we have gathered everything. We are gathering it one after the other, and we are agreeing that yes, the water is good, the pot is good, the rice is there. So, it gives us great quality to understand that, oh, this is exactly where we are going to. So we've got nice pots that we're going to use. We've got good water. We've got good rice. All these things, we are getting it at bare minimum. So instead of us to have just waited to just say, okay, bring a pot. And when we brought the pot, we haven't gotten water. Maybe the water we are going to get is still far away. Waste of time, waste of resources, waste of someone going there. That is more cost. That's the reason for this. But when I go further, you're going to understand it when I bring it to the software world. Now, SDLC provides a well-structured flow of phases that helps an organization to quickly produce high-quality software, which is well-tested and ready for production use. So now, see, let's take an example. That cup of water that we have put there, we've all tested it. Oh, I've tasted it. Oh, it's not an alkaline water. It's a very fantastic water, salt, mild. We've all agreed. I've tested it. It's gone through unit testing. It's gone through system testing. It's gone through all phases of testing. It's gone to UAT. It's gone to pre-prod. So that is fine. That is one phase that is fine. It has been tested well before it goes into production. So that's the concept. That's the concept behind software development lifecycle. So that's just a normal layman literal example of software development lifecycle. When we now bring it to the real world of software, take a website, for example, like Blue Sky website. When you were registering for the training, you had to log in, you had to register. Those concepts need to have been dug through, tested through that application. So before it went live, I know what all the testing that we did and things just to bring that platform to make it live for public, for everyone to use. So you would have tested, oh, we can register, we can log in, we can search for a course, we can make payment, we can do this. All these are processes, they are concepts that software development lifecycle embraces. So at that phase, the first thing, we didn't just bring all this, we didn't just integrate everything together. We started by looking at what is that platform going to be all about? What is the mandate of the platform? What is the expectation of that platform? That brought us to, okay, what do we want to do? We had someone to give us more of a design, to see an architectural design, a solution architect to bring that face up for us pictorially so that we can we can all visualize it and put in all our input before we can start building. Then we started with the bit form of it. Well, let's do registration. Well, let's do login in bits and pieces. Then before we started integrating it, that is how software development lifecycle wants us to do. And that's why we are working in an agile environment. This guy really loves agile. This SDLC is the one that preached it, bringing it to life for us to understand. So that takes us to another part of it. The reason why I chose this picture is just for us to have a clear understanding what a life cycle is. So I took this subset as an example. Chicken, let's take it. We all eat chicken. But chicken it didn't turn to an adult in one day. It started from the egg first. When this egg was laid, the next thing, this guy, the chick was growing inside it, embryo. From there, it hatched. So it's the hatchling. That's it trying to come out. Then the next thing we had was the chick coming out. Before we know, he's been feeding and eating, doing everything. It turned to an adult. That's a chicken life cycle. Bring it to we human. The first thing is that our mothers had us in their tummy. The next thing we started growing. It started forming as a baby. After all, after a while, 9 months, the baby is given birth to. After a while, it's 10, it's 20, it's 50, it's 100, it's 150. That's the way we humans do. That's the life cycle of a human. So that's the way the software development world too revolves. So that takes us now to the real world. So you see this example, you see, it started from somewhere. It moved here, it moved here, it moved here until it got here. So it started in bits, and it grew to an adult. It did not just get to an adult without it starting from this little plant. So that's the meaning of a life cycle. It's the same understanding of life cycle that you have. That's the same meaning we're going for. So that takes us again to the acronym, just for us to understand it. SDLC, they're just key things that I just want you to know about SDLC. Is the acronym of Software Development Lifecycle. It is also called Software Development Process. It's a framework defining tasks performed at each step in the software development process. So these are mainly the 3 key things. I just brought it as a point for you to know that, refresh your brain. When you hear anything about SDLC, when you are asked during an interview, just know, have you worked in an SDLC environment? Yes, I have. What's the acronym of it? Software Development Lifecycle, also known as Software Development Process. It's a framework. Just like the normal framework that people will follow, is just a due process. You cannot be, if you don't have an egg, you cannot have an adult. You cannot have
Lily.
So, sorry, please, everybody, just mute, please. Thank you. So that takes us again to software development lifecycle. I'm just trying to make sure that you are getting everything that you need to understand about, because there's another one coming, which is SDLC, which we'll get there. So the software development lifecycle refers to a methodology that clearly defined processes for creating high quality software in detail. The software development lifecycle methodology focuses on the following phases. So These are the phases that we use when it comes to SDLC. First, number one, requirement analysis. I'm going to explain everything in details for you. The second one is planning. The third one is software design, such as architectural designs. I've been saying that, software development, testing, and the last bit of it, development and deployment. And that is all the 6 that we need. And I will explain them in details for you. Requirement analysis, planning, software design, such as architectural design, software development, testing, deployment. So that takes us to this. So this is the requirement analysis. I'm going to show you the picture and I will let you know. So this is the software development lifecycle. Requirement analysis. So you do number 1 first. Number 1, we go, just follow this gray arrow. It takes you to green. Number 2, the design. So once the design is done, it takes you further to the development. So from the development, it takes you to testing, then testing, it takes you to maintenance. So requirements, who are the people that get engaged in the requirement? Product owner, business analyst, that's the brain. Those are the brains behind requirement analysis. The product owner, they are the ones that liaise with the client. They get the picture of what the client wants, bring the information to the whole team as a whole. Who are in the team? The team comprises of, I think I said that in the class. The team comprises of 1, a project manager who oversees, a scrum master, either or. So scrum master had to make sure that each of our activities, he or she removes all the impediments, blockers. He can reach out, help us raise tickets, do the necessary things to keep our job going without it being blocked. The next thing we do is, after requirement gathering, there's a design phase. What design? We get a solution architect, an architect to say, oh, this is what the business analyst wants. It tells it to him. We take it, oh, this is the picture of what you want. He draws it into the picture. Then it brings it to development. The development team involves the developers and some of the architects to engage with them so that they can align to what the requirement is. After that is done, then it comes to you and I. We as testers, we are the goal to say, if this thing is not as expected from what number 1 gave me, then I cannot move further. Likewise, after development, then it goes to maintenance stage. That takes me to SDLC, waterfall. So I'm going to start with each of the model one by one. So I take waterfall. Now, if you look at this model, look at it. It looks like waterfall. That is the concept of it. That is the reason why it's called waterfall. So you can see it's falling. The requirement is falling to the design, to development, to testing. It's a falling method. That's the reason it's called waterfall. So the first thing you do, as I've said initially, is requirement, design, development, testing, deployment, maintenance. So once the requirement is gathered by the business analyst, in waterfall, the concept behind waterfall is this. Requirements, first person, which is number 1, requirement gathering, is done by the business analyst. All of us that we are here, from design, development, testing, deployment, maintenance, we all sit down, we wait for the requirement to be gathered. If the requirement likes, maybe the business analyst gets all the information next 2 to 3 months, we all are here. We'll be sitting down and waiting for the requirement. We can't do anything because we won't be involved. So once the requirement is gathered, it takes after 3 months, maybe that one used 3 months to gather the requirements. It brings it to the design. The design team will look at the requirement and say, design team, oh, this is going to take us another 8 weeks to do it. Every one of us here, we all sit down to wait for 8 weeks. Don't forget, we have waited 3 months before. Add 8 weeks, that's 5 months. We've not started anything. Nothing has started. So 5 months, we have been paid doing nothing. So after a requirement is done, then we've got the design phase, then we've got the deployment. The development. Let me go back one step again. Once the requirement is done, the business analyst's job, he sits and waits for us. He or she is not involved again because it's a waterfall model. Then the next thing goes is the design. After he has collected the requirement from the analyst, the design team will do their own bits. They too, once they finish, they put it to development. The developer will look at it, he will bring it, he will develop it and do everything. Even if he has questions, he just have to develop whatever he has. Then the next thing, they bring it into testing. Testing with test. I don't know everything that is from the beginning here. Testing with test. We'll keep testing, we test, we find different bugs, do everything. We can't do anything. They will do the deployment and maintenance. That's the process. Now, let's come to it. I said this guy here, the requirement guy, actually did this for 3 months. Design took 8 weeks, that's 2 months, 5 months. Development took another 3 months, that's 8 months. So 8 months. Testing is going to take another 1 month, 1.5 months to do that. So look at 1.5 months with it. So at 1.5 months, testing comes back and find out we have already spent almost 1 year. We have not done any testing. Then I started seeing bugs, no understanding, or I just logged in, everything crashed. Do you know what will happen? We are going to go back. We cannot move further because if it crashed, we'll have to go back. We'll not take it back to requirements. Start all the process from the beginning again, requirements, design, development, testing, deployment, maintenance. So if we find any error here again during testing, we go back again to it. So it's not done systematically. It has to be, if one phase is not finished, we can move to the next phase, which it takes longer. Don't forget resources. You and I are resources as long as you're working on the project. You are paying people for 10, 12 months without doing anything. So all these things are the reason why a lot of models were coming forth after this. So that takes me to the next step, to say linear. What does it mean? This means that each phase, this is the requirement phase, design phase, deployment, development phase, testing phase, must be completed before the next phase can begin. So each phase needs to be completed. Phases do not overlap. For each phase, goals are defined. They must be achieved and signed off. So you can see how long it's going to take. I just said, so when I go for that, you'll have an understanding of it. That is the user or business required are defined. The next thing is design, system design, architectural designs are defined. Deployment, code is implemented in small program units and tested. Then we've got testing, test plan, test script, system tests. System is tested end to end and user testing is done. These are the things that are done at each of this phase. When we go to deployment, product is released into customer and user environment. That's what deployment does. It takes it to the environment that we need to use this, the maintenance. So to resolve customers' environment issues. So these are just the phases. I'm still going to deep dive into it to explain more to it. What is the advantage of this? The pros. Phases are processed and completed one at a time. This works well for smaller projects where requirements are well understood. Let's take, for instance, we understand how to cook rice. So we know what we need. So we know all the ingredients that we need. We are not going to miss anything out. It's a small project. I know I need a cup of water. I can measure the water I have. I need a pot. I need raw rice. I need salt. I need a burner or electricity to do that. I know those 5 things. That is what I need to use to cook a rice. So I can't miss it. Because it's small, it's so little, so you cannot miss that process. So you can use waterfall for this kind of project. It's very small. It's just like you want to do maybe a 1-page website, and it's just that people should just be able to see that website, just 1 page. They're not doing just for them to read content there. If you know everything that you just want to be on that 1 page, they are not navigating to anywhere. Fantastic. This is waterfall can work for it. That's an example. That's an advantage. But what is the disadvantage? Complete a stage before moving to the next. If something is wrong in later stage, there is no chance of going back. You have to continue it until you finish it. I have found a bug at testing level. I cannot do anything. They just need to move. I need to move it to deployment, and it needs to move to maintenance before we can go back and start all over again. Look at the time we've wasted. Look at it's expensive because we all have taken all the money for 12 months. Then we are now starting all over again for another 12 months. How long are we going to finish? That's the reason for it. So that is waterfall. Remember this diagram, remember the process. That takes us to the next model. So before I continue in the next model, I want to bring up some things. Let's do requirement gathering and analysis. The first thing is that we as testers, you understand the proposal put forth by the customer and then gather their requirements for a suitable solution. This is the job of a business analyst. I can say that again and again. But in rare conditions, you might get to an organization where we don't have requirements written and we don't have BAs available. Example, at that phase, you can use experience-based, but I will get to that side. This time around, just configure it that requirement to be gathered by business analyst. I would explain that side to you when it gets there. Be sure to probe as much as possible to gather as much information as you can at this stage. So when you are given a login, let's take login, for example. Before I take login, when they brought the rice to me, I told you there are different variations, different types of rice. We have basmati, we have easy cook rice, we have long grain, we Africans, we have one that they call ofada, is like brown rice. We have brown rice. So that's 4 types of rice that I have mentioned. I need to ask, what exact rice do you want? Rice? Is it white rice? Is it even the white rice? Do you want basmati? Do you want easy cook? Do you want long grain? What exactly? Be specific, probe, ask questions. That is when you ask them those questions, it brings them, oh, if you cook white rice, do you think if you use the basmati rice, will it be that white? Okay, what do you want? How do you want your rice to look like? Then the client will be able to think to say, okay, I want it colored like, I want it pure white, long grain, let it not be soggy. Is giving you those characteristics. You start gathering it. That's what the business analyst job is. This phase is heavily documented so that developers can revisit requirements at any times. Who are developers? You also, as a tester, you can revisit it at every time. That's the requirement gathering phase. Then takes us to the next phase, planning and design. This is when you elaborate on a project plan for meeting those requirements laid out by the customer. So now that customer has asked that long grain rice. He has given us, he said, don't make it soggy. I want it pure white. It should be crispy. It's just giving you different criteria that he wants that rice to fulfill. So now you as a tester, you want to imbibe everything. Test to ensure that the rice is not soggy. So you need to know the number of quantity of water to be used. Test that, of course, ensure that it's basmati, validate it. That brings us, let me take you again away from the real world. Let's take it to software world, to our own application world. In the login, they've said to be able to log in into a website, one, it must have a user ID. The user ID, you could ask, what do you mean by the user ID? Is it with an email or a username? So, oh, the client might now look at, oh, that's true. Can we use both of them together? Yes or no? No. Yes. We can try. We cannot. Okay. We don't want, let's use email. So the first thing is that in the criteria, the acceptance criteria, the client has said use email. So it will be username/email or email. Username in bracket email. Then password. In the password, we need to clarify how long do you want the password to be? How many characters? What should the characters involve? What are the steps needed? Those gatherings, those quality, oh, we want it to be four letters. It should be 4 characters, comprises of letters, special characters, and symbols. That's one phase. So those things are what we now, as testers, we work towards. We are going to design our script. So all these things, please have it in mind. Once you have a plan, design concrete specification for the to the developers to utilize, like screen layouts and other materials. That's where you do the design, the architectural design. They give us a pictorial one to say, oh, this is the structure, this is how it's going to look at. Then during this phase, you need to analyze the problem in the context of the organization policy and objectives. I'm just explaining those phases for you so that you will know what happened in each phases, what discussions are going on within this phase. So you can say that this phase, these guys that are involved in this stage 2, planning and design, are the solution architects and the business analysts. They are telling us that, oh, this is the requirement she gathered for the login. So they will draw a picture, a structure for us to see from there. So the next thing is building. What are they building? At this phase, that's where the code is involved. Development, that's what you are doing. During this phase, the actual code is constructed. This is done by the developer. That is it. This can be done by a single developer, a large team, or even several teams, depending on the scope of the work. So it depends on the size. It depends on how big the project is. Developers will need to track their changes to the code. And if there are different teams working together, that they are able to know what others are doing. Changes should be documented either formally or informally. I always prefer documented so that at least let it be formally. Let's know that this is the shared location where you can see the login feature. This is what the code entails. This is what is written there. This is the expectation of the code. This is what the code is doing. From there, it gives us the visibility to know, even if developer A leaves, when developer B comes in, he picks up and he understands. And that's the reason for the documentation. That takes us to the fourth one. Testing. Who are the testers? You and I. This is our job. Now that the code has been written, it is time for us to test. Usually, it's done in a special environment. Here, you'll be given a test environment. On each of the projects you're given, you will have a test environment. It's not live. It's just within the team. It's just within you people. Whosoever you share the link with, that's the person that have an access to see it, so that the team can check for bugs and other mistakes without being distracted by too many variables. So these are the things that you need to, we as testers, we check, we manually check, but there are processes that we testers need to do. We're going to talk about that still in the class today, if time permits. If not, tomorrow we'll continue. So we see the next one is deployment. What's deployment? After all the errors have been eliminated, the software is deployed. This is when the product is actually put into production and released in a business environment. Then that takes us to the final part, maintenance. During the maintenance phase, the software is maintained so that it stays effective and relevant. Tweaks can be made to the initial software so that it remains a viable solution that is free of bug. The maintenance stage is just, let's be sure that, because this is now live, ensure that everything, little things that we need to change, are there any bugs slip through, let's be able to fix them, do things, and we go live for users. So these are the phases that I've explained in each phase. So we sit in number 4, testing. When it comes to testing, that's where we as testers sit. But everything will be consolidated when it comes further. So that takes us to software development. We are still continuing. So the first part I mentioned was waterfall. I only gave you a deep explanation of each of those phases that we touch in waterfall. Now we are going to the second person. This man here is another lovely man. So this time around, the concept behind this model, you will see the reason why we said the concept. What are the concepts? With the concept behind this model, let's look at it. It's V model. Look at this picture here. It says V model. The reason for this is because it's a V shape. This is how letter V looks like. Now, ask me again, how does this concept be? I want me to go. So how is this concept like? So in this concept, user on this side, this side, and this side, I want you to look, there's a trick behind V model. So when user the requirement, you said I've explained all those levels for you, requirement gathering, we've talked about building, design, building, testing, deployment, maintenance. Those 6, we are bringing it into this V model now. Everything, what I've explained initially, from waterfall is still a concept that we have brought together to looking for easier method, easier ways to make this thing work as expected and give us high quality. That's the essence of SDLC. So we are testing in right frame and we are testing in little by little to make sure things are working as expected and quicker. So now vModel, this phase now, we get the user requirement. So I'll call this phase is on the left side. So I'll say user requirement. So for every user requirement from here, if you go to this, it's got an acceptance testing to validate the user requirement. So what the process that is done is that you do an acceptance test plan to validate this user requirement. So business analysts are written he or she has written the requirement. He has gathered the requirement. We as testers, our job is to do an acceptance testing. So we do a static testing. We do it to accept that. Do I understand what you have written? You said the login. This login is ambiguous. Can you tell me what are the acceptance criteria there? How many characters is going to involve? What is our expectation? How many attempts are meant to be done? How is this going to be done? So those questions will be bringing the business analyst to understand. We are still in this one phase. So if this phase is not done, we can move to the next one. So as long as the next phase is done, then we go to this software application. Now, what is done at this software application? We do a system test plan. So as the software application is done, just more of a design, we do a system test plan to validate it. So which system testing is to validate it? That's it. It's going to verify whatever is here. So the next phase here. So as you're doing this, as the software application is being produced, a validation process is there. So which is system testing. Then the next thing is high-level design. What are the high-level design? We do an integration plan. Integration testing will follow up to check it. Then the next thing, we do a detailed design. The detailed design, this now involves unit testing. That is where the code, the big brain, the code will now start the code deployment and the code development. So what vModel is preaching here, what vModel's concept is all about is that at every phase, there is a testing phase to validate it. Now, everyone, another question, another twin brother that I want you to bear in mind is verification and validation. Verification, validation. I am verifying. I am validating. When you are verifying, you are looking at and verifying, is this the product? You are verifying that, is this what the client has asked us to do? That is verification. So you are following it. Is this what the client, did they say we should boil water? We should use white grain rice? We should make the login. We should add this. Is this work as expected what the user is doing? The next thing with validation, now you are verified. I want to test it. I want to validate it. Really, the user has said it must be login should have four characters. Why am I having 10 characters? Why is it allowing me to do 10 characters? If it's maximum 4, if it's minimum 4, then it should not accept 3 characters. You understand? So verification is, am I doing as expected to what the user is? Validation now is my actual. So verification is like my expected. Why validation is my actual. I am looking at you now. This twin brother, don't forget, I've given you expected actual. Remember, exit entry criteria. Now I'm giving you verification validation. Twin, they must. These two, I can tell you, If I'm doing an interview for people, most of the time I love to ask this question. I will know who my testers are. So this one of the questions you should bear in mind. They are interview questions. So as I'm remembering interview questions, I put it forward to you. So now let's go to each of those phases. So you will see me here. I did verification phase and I did validation phase. So at the business requirement, so each of these phases that you see here, I try to explain it here. Now you might think that I'm explaining it so much in details. The reason why I do this is to ensure that when you get to the field, it is you understand the concept. When people start mentioning some terms, we bring some terminologies in. They you would just, when you hear software sequential development model, oh, this is a big one again. It's big. Meanwhile, it's not as big. It's just the words. People use big words to feel, then you think that whatever they are doing is as big as that. No, it's not. It's just for you to understand the concept. So that when you want to answer people on the field of work, you will understand, oh, it's talking about verification and validation phase. So tell me, what do you want? Do you mean verification and validation? Then you say yes. So you have made him know that I know what you're saying. So don't bring something in that I don't understand. So the first one is business and user requirement, which you see here. And I told you that the person to attack this person is the acceptance testing person. That's the person that is going to verify this. And this is what is going to validate it. Yeah. So user business or user requirement, detailed requirements of the software system to be developed are gathered from clients. So what is acceptance testing? Involves testing the product in user environment. So you look at it, you test it, you validate it, see how it is going. And then the next thing is software application design. How will the system work and interact? That's the integration phase. Functionality or features that goes into the system. Those are the things. So checks the entire system functionality and the communication of the system under development with external systems. So it's just merely an integration phase. Checking it, looking at how things are coming together. That takes us to architectural / high level design. So the high level technical details of the product, that's one of the things that we do here. The coexistence of the components that make up the system, that's another thing that happens in this phase. Then in this other phase, the validation phase, is the integration testing. So integration tests are performed to test the component, the coexistence and communication of the internal modules within the system. Is just looking up at the integration, ensuring everything is as expected. Looking at the code, when you say, when I log in, what is the next thing that I need to see? When I go navigate from here to the next thing, so the sequential way, the next phase, that is what these things, that is what it is testing. Then the next thing, we go to the model design detail. In this phase, that's the verification phase. Once your system is ready to use, you may later require change. That's change to the code as per customer request. So anything can happen at the verification phase. At the validation phase, unit testing is involved. So what you do is that tests individual models or components. So you have taken the login. Login is one code. You keep it somewhere, you test it properly. When you navigate to, when you open search, search is another code, it's a model, it's a component, it's a bit. So let's say cup of water is one model. It's one code, is one model, is one component. Pot is another component, is another model. They are bits. Rice is another component, it's a bit. So that's the way it is. But don't forget, all these are still the ingredients. The integration phase is when we put everything together, pour water in the pot, cook the rice, add salt, let it cook to done. That is integration. I have brought everything together. That is what integration means. You have linked it together. So at this phase, coding phase, so you code build, coding guidelines and standard, code the review, code optimization. Is meant to happen in the coding phase. You must do a build, you must have the code guidelines. That is, those things are key. There are guidelines and standards that actually work with codes. That will be validated by the developer. Any developer, before they deploy into a dev environment, they always do a code review, either with a tester or a tester and a developer, or they do with a developer. Likewise, they do optimization to ensure they've got a clean and robust code, a simple and not ambiguous, so that when it goes in, we can be able to debug at any phase if there is an issue. Furthermore, it's a continuation of the V model. So, sequential. This means that every single phase of the code of the system, of the code, it means that every single phase in the development cycle, there is directly associated testing phase. And that's what I've said initially. This is planned in parallel. So that takes me to what's the meaning of verification? Verification. Are we building the right product? That's the first thing. When you were boiling the rice, putting the water into it, are you sure it's the right thing that the customer is asking you? I hope it's not the brown rice you are cooking. It's the basmati you are cooking. That's the verification phase. The validation phase. Are we building the right product? Does it meet the user expectation? Does it meet the need as it intends? Is it the expectation? Is this the expected? That is what validation is. Verification. Are we doing the right product? You are asking yourself. Validation. Now, we have seen the product. Is it the exact thing that the user wants that we are doing? So that is verification, validation. Please don't forget. So that takes us to advantage. What is the advantage? Testing in early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. That's it. What is the disadvantage? Is a drawback. Is a major drawback of V model. If any changes happen in the midway, then the test document along with requirement document must be updated. Let's say, for example, at this phase, we have accepted it. Maybe when we finish coding, the client might come back to say, oh, I don't want the login to be minimum of 4 characters again. I want it to be 10 characters. We have to go to each of these documents here. User requirement, acceptance test, all these phases, every document that is here, you need to update them accordingly. So you can see that if we don't update it accordingly, we can't even start coding immediately. So all this will bring it back to give us a more drawback when it takes to take this one. When it takes us to, when it comes to V model, that's just the disadvantage about it. That takes us to this part. This is the interesting part of it. So this is the third phase. Now, don't forget, when I started the learning curve, our learning objective, I gave you of SDLC models. But I told you there is three guys that are key. Waterfall, which is the linear model. We're talking about view model, which is the sequential development model. We now, the last one, which I said the iterative model, which is called agile. You now as a tester, where you are doing now is agile environment. Look, any job you are looking for, they will ask you, have you worked in an agile environment? You say yes. Because you are doing this internship, you tell them, yes, I've worked in a fully implemented agile environment. I do my daily scrum. I do my your daily scrum or daily stand-up. You do your sprint planning. You do your sprint review. You do your sprint retrospective, grooming session. All these are agile ceremonies. So you are doing the exact thing that is viable in the market. That is what you must have an understanding of agile environment. There is a role called agile tester role. You as a manual tester can do it. You as an automation tester can do it. So these are things that I want you to know that we are doing. So what is this model about? Please. So we take the first model to say incremental iterative. So what the concept behind this is that requirements are broken down into multiple standalone models of software development lifecycle. Let's take an example. This iterative model, you see number one, that's the first bit that we started. I just took alphabet number one. Then the next thing, after we've built number one, we go to number one, we take number one plus, we have not even moved to the next one. Then after we take number one, we build number one plus. After we have achieved that, we've tested it, everyone is happy, then we take it again, we go to the next one. We have built number one plus, then the next we take number one plus number one again. That's another model. That's another that is another component. We take it again. Then we take another one. We have done one plus one. Now we want to make it. Don't forget, my end point is that I want to get two. I want to get number two as my answer. But I don't want to do it in a rush. I want to be doing it simplest way so that you can understand. That's why I said it's one plus one that I'm ending. It's two that I want to get. So I will do it to say number one. I take one again, one plus, I build it. After I've done, after I've built one, I will bring it again to say 1 plus 1 is equals to, I have not done the answer. Now I need to count it. 1 plus 1. 1 plus 1. Okay. Bring it now. Let's do the answer. I've already done 1 plus 1 is equals. So now let's count it. 1 plus 1 is equals to 2. That's my end product. You see that we broke it down into simplest way for you to be able to understand. So the next thing is each iteration process through this requirement, through the phase. First, requirement is done, design, coding, testing, software, and product incremental. So let's start. First, we build number one. When the developer builds, no, the requirement is being gathered already. Business analysts give us immediately. Solution architect, they bring their own, or the business analyst gives us the wireframe. We've looked at it. We've built our own test script while development, the devs are working on it. We've started planning. We've done our own script. We've done everything. Immediately, they gave it to us. We finished development. We start testing. Oh, I found a bug. We went there, we sent it to him. He fixed it. Oh, everything is working. I did retesting, regression testing. That phase, number one phase is done. So I know number one alone is working as expected as at now. We've tested it, it is fine. So the first phase, requirement gathering, design, coding, testing, software, product increment. That is it. So the next thing, I go to the next phase, number one, plus. So we do number one, plus. We go, we gather the requirement, do everything, requirement, design, coding, testing, software, product increment. We go to the next phase. That's the way it's done. So we know that at every phase we are testing early and everyone is coming together. Within this sprint, we know that is number one we want to do in sprint one. So everybody sits on number one. No distraction. We all sit together. We do our script. Developers are coding. The business analyst has done our own requirement. We are also, the deployment is done. We've kept the code. It's tested in seat. It's tested in UAT. It's tested. It's sitting there ready to go to pre-prod. And each subsequent release of the system adds function to the previous release until all design functionality have been implemented. Iteration output, partially delivered product. The process is repeated until entire product development is completed. The repetition of these phases are called iteration. First iteration, second iteration, third iteration, fourth iteration. So that's the way those things are going. Each of these phases are called iteration. For every completed iteration, a product increment is delivered. So when I finish one, I add another thing to one. So when I take a cup and a spoon, I put the first spoon of water. Once that one is done, is into it, I take another spoon of water, I pour it in the cup. It will increase. When I put another spoon, it will increase again. If I put another spoon, it will increase. Fifth spoon. So it will be going higher. It will not reduce as long as the cup is not leaking. So it will keep going up, 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 up until we finish the development. When is this used? There is need to get the basic functionality delivered fast. That is when you use it. When you want your functionality, when you want to be having a good when you want to be talking to the client, for the client to be seeing your product immediately, to, oh yes, we have delivered this, is this fine, is this what you meet, is this your expectation? Yes, it is. Oh, change here, we quickly change it to suit what he or she wants. Then we will know that he has signed that bit off. That is when you use it. What is the pros? The advantage: quick delivery to the market. Customers can provide feedback to each product increment, thus avoiding surprises at the end of development. Requirement changes can be easily accommodated. Look at vModel. Any requirement changes, it means you have to change all the document. But this one, we are still in the sprint. So we can change, you can add, you can remove, you can subtract, you can do anything. Because we are still within the sprint, we are still doing number one. We have not moved further. I've still just poured one spoon of water in the cup. So it's still at that level. So that's the reason it's quicker. Then what is the disadvantage? Requires effective planning of iteration. That's it. You must plan your iteration. You must know how you people want each of your sprints to go. That's the disadvantage. So that takes me further to you seeing. I just give you an example so that you can see it. Picture. When you see things like this, it sticks to the brain. So that's the reason. So let's take the first one. First iteration, requirements gathering, we analyze it, we design it. In the design phase, that's where we test, we do everything. We do that's the architectural diagram, the code, in the code. Then we do, we have tested, we have done everything. Then software product is done, is delivered. Once it's delivered, that's the first iteration. We go again to the second iteration, requirements, analysis, design, coding, testing, everything is done. Then the software product increments to 2. So when it increases to 2, iteration 2. So go again, requirement, analysis, design, coding. Then the software product increase to 3 until you get to the final product. So when you get to the final product, your product it can be a sprint 10, it can be a sprint 20, it can be a sprint 5, it can be a sprint 4. It depends on how big the project is, and it depends on the deliverables at every sprint. So this is an example of an agile methodology. So that's another way. So now let's take the agile picture side of it. So definition of ready. What does this mean? Are we ready to go? Do we have the mandates? Do we all understand as a team? When I mean as a team, business analyst, developer, you as testers, developers, all of us, we get involved in the project from the one. When it comes to agile, from the one, we don't wait for requirement. Once the requirement, oh, today I've gathered this requirement, we all come together. We discuss about the requirement, because when we discuss about the requirement, it gives the business analyst chance to be able to think also, and also go back to the clients for more questions, for us to get to understand it. If you bring things to me as as um as a tester, I come back to you, I will ask you, I don't understand it. So we can be, during our discussion, more of a grooming, or when we are looking at everything right from requirement gathering phase, we start asking, when I've done my static testing, oh, BA, what do you mean by this? What is your expectation? Can you expect? And you start jotting everything down so that you have good coverage. You are able to touch every phase of it. That is the definition of ready. We have everything. This is what the project is all about. Then what is a backlog? Then you move it into the backlog. All the tasks that you people want to, everyone we all want to do for this project will be moving to the backlog. The backlog is just like a bucket to accomplish everything we said we are ready for. The ready means we have every information, necessary information that we need. We have gathered it. Now in the backlog, we have broken those information into pieces for us to know what we are going to do. Then the next person, he takes it into sprint. Who is the sprint? Sprints are done in normal agile manifesto, is meant to be done how the organization wants to have it. Then it might be more than 2 weeks, it might be 3 weeks, so 4 weeks. So it depends on how releases are done, what the expectation is from both the project side, the client side, and also from the business side. All these are put into consideration before we do it. But an happy part, a good agile manifesto, what it says is 2 weekly. So I'll follow this, say the normal way of 2 weekly. So the 2 weekly after the sprint, in the sprint, we want to do this sprint, we are dealing with logging only. So in this sprint, we all have we understand that is logging we are going to do in this sprint. So the developer, testers, business analyst, data analyst, whosoever is within the team, or is logging. We all start breaking our tasks. Then once it's logging, it goes to development stage. The developers start doing their work. While they're doing their work, we testers, we're already prepping. We've written our test plan, we've written our test strategy if needed. We started designing our test scripts. So all that would have been part of our test prep. That would have been our test bed. We are laying it down before anything comes on it. So you want to arrange your bed. You want to make sure it's clean and clear, so that when someone comes on it, then you are able to start immediately. So those are the things that are part of our test prep. Then once the developers finish, they move it to test. So for testing, we do our system test, integration test, every phase of testing. Talk about regression test, retesting of bug fixes, functional and non-functional testing. All this will be done on it to end. And after then, we take it to integration. This is the integration phase. So at the integration phase, then you'll be able to ascertain what is everything has come together, is fine. Yes, we have finished logging, happy, bug fixed, everything is done. Then it goes out to the client. Are you happy with this? Oh, what do you want us to tweak? We go back, we fix it, we do it, bugs, everything process, regression test, functional test, non-functional, anything that we need to perform would have been done. Agreed, signed off, developed, yes. Then we are done with that sprint. Then we come back again, sprint 2. We start again from the backlog. We pick it here, we go here, go here, go. That's the way we'll finish the end sprint. So what you've seen previously from here is just another picture of it here. So that's the way it goes. So that ends exactly. I'm just giving you another face of it. So this is agile. You see that I really took my time for you to understand that agile. I'm just giving this is the stage. This is the environment you're going to be working with. This is the methodology you're going to be using. Agile methodology. We've done V model methodology. We've done waterfall. But the major methodology you're going to be using is the agile methodology in this. So requirement, design. So build 1, you design and development, design and development, testing, implementation. Build 2, same thing. Build 2, 3, design, development, testing, implementation. Build 4, same thing. Build 5 until you get to the end build. So that takes us to the end of that phase. So the next one I really want us to talk about is software testing lifecycle. Software testing lifecycle. So I'm going to stop here because I want to give you time to ask me questions. But prior to that time, looking at it, I can do it. So the previous one was SDLC. Now is software testing life cycle. STLC. Testing life cycle. So everything I've been saying predominantly previously, I have now streamlined it to we as testers. That is what this concept of software testing life cycle. So it's between you and I. You need to now understand that this is our own job. This is where we are coming from. The software development life cycle is the whole team, correct? The whole team, which comprises of developers, scrum masters, BA, project manager, solution architect, the data analyst. That is development. Now it's streamlined to this word testing. So it's now we as testers. So what does it entail? The first thing is when we get the requirement, we do test planning. We do the test design, test planning, writing, putting all our testing artifacts. When I mean testing artifacts, talk about test plans, system test plan, test strategy. All these are the things that you're testing with. You test design. What are design? Don't forget that brings us to the two principles. Brings us to our principles. The first one we have done was the general testing principles, which entails part of software development lifecycle. Now, fundamental test process is talking about you and I, software testers. So that's in our fundamental test process. Remember the second phase. The second phase is test, design, and analysis. That's where it comprises us here. The first phase of it was test planning and control. This is us here. So the next thing is environment setup. What is environment setup? You want to get your test environment. What environment am I going to use? Am I going to involve, is it going to involve using tools? What types of tools am I going to use? So we need to know the types of tools. This time around, your tool here will be Azure DevOps. So you need to have an understanding of it. What test environment are they going to give us? Are they going to give us an endpoint? What is an endpoint? Endpoint is the URL, www.google.com, www.bluesky.com. That is endpoint. That is URL. That's the same thing you'll be giving. https://bluesky.com. That is your endpoint. That is your URL. So that all those ones, we need to make sure that they're set up for us to start testing. The next thing is test execution. Remember the third phase of our fundamental test process. Remember, fourth phase of our fundamental test process says, the third phase says test, implementation, and execution. This is where it falls here. Then the fourth phase tells us that executing exit criteria and reporting. Then the final phase of it says test closure report. You can see that what we have done in fundamental test process is what we want to bring together for software testing lifecycle. Correct? That's where we're going to. So that takes me a bit to what is STLC, the acronym. We said it, software testing lifecycle. STLC stands for software testing lifecycle. STLC is a sequence of different activities performed by the testing team to ensure the quality of software or product. STLC, guys, is performed by us as tester. Development is by is streamlined to testing team. What is the role of the STLC? Even with the most talented, highly skilled team of developers, mistake still happens. Mistake still happens. You know the irony of it? Let me tell you, please bear in mind the mistake that you will always find. Developers and testers, we are very good friends, very arguing friends. The developer, you tell you, it is working in my own environment. By the time they develop, they drop it in the test environment. It's not working. Now you'll be looking at yourself, don't I know what I am doing? No, it's not like that. It's not you. The question is it working in your environment? Always remember, anytime you are testing, please have it at the back of your mind. You must take a screenshot. The easiest way to get a screenshot is by searching for snipping tool in your computer. We have it. When you go to the task bar, search for snipping tool. We all have snipping tool. You can use it to take a picture, a screenshot, a snapshot. Reason is, for example, if you take a picture of yourself or someone takes a picture of Yami, my hair is braided, I am wearing a blue dress, and they took me with the picture, braid, blue dress. That's the picture I have. There's nothing you want to do again. when you show it to everybody, this is Yemi. She's wearing a braided, wearing a braided hair. She's wearing blue top. That is the picture. Nobody will come back and ask you that. No, that's not Yemi. It's not Yemi, it's a man. No, it's not it cannot be because I'm here. Yemi is wearing red. No, you can see he's wearing blue. The picture is with you. You can see he's wearing blue. So when you take a snapshot, ensure you take a snapshot from the URL down to the whole thing on the page. When you put a screenshot in your bug, the developer will not come back to you. I'm telling you, they won't come back to you because when they have seen the URL you have stated, they have seen it in front of it that it is not working in Yemi's environment. The reason why it might be working in a developer's environment is that their environment could be more configuration good because they need a stable, well advanced config to be able to do their unit tests, accommodate everything to work as expected. But from the testing view, the config that we are going to have might be different. What is going to be UAT will be different. What will be in pre-prod will be different. Pre-prod is like a mirror of production. When I mean mirror, when you look at the mirror, if you look at yourself in the mirror, is what you are that you see in the mirror. So production, pre-prod is pre-production. So this is pre-prod, but we as the team, testing team, we are still testing here. Production is now for everybody to test, for everybody to use the application. It's live. So now, the issue you will be having with developers and testers is that it's not working in your environment. Now, interview question. You'll be asked, have you worked with, have you had any issue with a developer? It's always a asked question. Yes, you've had an issue. What's the issue? Oh, when I was working at, um, I'm giving you, okay, let me give you my own view. While I'm working at this insurance organization, I was working on a modeling review project. While I was doing this, I logged in I tried to launch an application. Unfortunately, it wasn't working in the integration environment. So, but it was working in the dev environment. How did I resolve it? I took a snapshot, step a step to reproduce it, and I sent it. After we have found out it's not compatible on that in my own environment. Simple. So, how did you resolve it? That's a situation. What, because I use the STAR approach: the situation, the task, the action, and the result. The approach. So, in my own approach, what I would do is, let's go first, look at the config that we have in the dev environment, come back to testing. We look to ensure we set our own configuration, do the right deployment, and that was how it worked. And the result is eventually I was able to launch the application in the test environment after the right configuration was done. That is it. That is an interview question. Simple. I'm not going to say anything other than that. You have stated the situation, you have done the task, how you carried your own this thing, you've done the approach, and you have stated the result. What is the result? The end product. That's it. So, as I've said, even with the most talented, highly skilled team of developers, mistake can still happen as a result of human nature. That's what error is about. Error, error, defect, failure. The role of a software test, the role of the software testing lifecycle is to identify any mistake that have been made and find solution for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. That's the key things that we have. That's your role. That's what this is all about. Why is this? So the next thing is, what is the STLC phase? The software testing lifecycle consists of 6 main phases, each of which involves specific actions designed to ensure that a high standard of performance and quality is achieved. What are the 6 main phases? The 6 main phases of this SDLC are: 1, requirement analysis, test planning, test case development, environment setup, test execution, test cycle closure. That's what I showed you in that diagram. Let's take it one after the other. Activities. Activities in requirement analysis. The first activity is identify the types of tests to be performed and designed and assigned to the development. So the first thing, identify the test to be performed, then assign it to development. The next thing, gather details about testing priorities and focus. This is your own activity. The third thing you have to do, prepare the requirement traceability matrix, RTM. Requirement traceability matrix. I was still maybe a colleague, I know if she's online or maybe she's watching, I was just discussing this with her, just trying to put her through today. And I would have wished she was just here, but I don't know if she is. So, but requirement traceability matrix, as I've told her, every requirement, you must trace it to a test case. So login must have a test cases assigned to it, positive and negative scenarios assigned to it. Accept all those acceptance criteria, the white rice, everything, every ingredient must have a test case assigned to them. Correct. So that's the way it links you to the. What I always do is that in my first page of my document, I put the requirement. I was given just 9 requirements for a big project. Nine requirements for different application. And I told her, I can tell you predominantly, I wrote over 250 test cases. But each of those test cases, out of that 9, I can tell you there's one that I cannot perform because my access right cannot give it to me to perform. This can only be done in production, in live. So I had to move and when I did my own closure report, I stated it there. In fact, before I even started doing the closure, I've explained to them that, look at this requirement you have written here. It cannot be performed by us because I've gone through the business users. I've asked questions about that. I've been given that, Yemi, you can't do it. It can be done in prod. So though I have access to production, I cannot do it. The only thing I can do is that, because if I do it in production, someone needs to delete that data immediately. So I need a user to do it for me in production. I will validate it there. If there's any issue, we quickly take it back and do it, and they will deploy it to production. So, but I have mapped all my test cases to that. Reason is that when you get to production, bugs might slip into production. Now, the question they will ask you as a tester is that, what exactly did you test? But when you tell them, this is what I have tested, this can happen, nobody is going to query you that you did not do your job. That's where it sits. Because bugs, when you have tested in test environment, it goes to UAT, that's user acceptance testing environment. It goes to pre-prod. It should have caught it in those 3 places, in 3-4 places before it gets to production. So it should not even find its way to that production. So whatever should be in production should be maybe existing bugs or something mixed with each other. It shouldn't be, because we have gone through different phases. Then the next thing, identify test environment details where testing is supposed to be carried out. Identify test environment details where testing is supposed to be carried out. So different environment are the things I've mentioned now. UAT test environment is for we. UAT users pre-production and production. Conduct automation feasibility analysis if needed. Clause. So those are the activities of requirement analysis and gathering. Deliverables. So I'm going to stop here tonight. I'm going to stop here tonight. So now, tonight, I'll stop here. I'm going to open the floor. But before I open the floor, let's do our fine class. So you just be opening. The rule is if you've mentioned something, if you understand, please and please, you have to give, everybody have to participate. If you don't talk, I'm looking at your names. I will call your name. If I know you are not talking, I will call your name because I want to make sure that we are all following. I would have loved to continue, but I don't like to give too many information. It's too much for a night. So that's me. So we can continue tomorrow. So first is, what is SDLC? What's the acronym for it? First person, unmute yourself. So much, Dorcas. Thank you. So for the software development lifecycle, what is software development lifecycle?
It's the process that produces software with the highest quality and lowest cost in the shortest possible time.
Fantastic. Thank you so much, Abiadu. So I'm giving Comfort one lolly, and I'll give
Abidemi.
Abidemi, I'll give you another lolly. In fact, yes, I'm even
Thank you.
2 lollies. So you see, don't worry, everybody, just send me your postcode. I'll send the lolly.
Okay.
I will even send it on the text emoji. Yeah, good, fantastic. So the next one is, we have various phases in software development lifecycle. Before I move to that, can you tell me the types of software development lifecycle models that we have? Number one, any type.
V model, that's sequential development model.
Fantastic. Emmanuel, lolly, one lolly. Good, good, good. Next person.
Waterfall.
Fantastic. Comfort. One lolly for you. Oh, Gani. You said what, Ganiet?
Oh, the iterative incremental development models. That's
What's
agile.
it called? Fantastic. 2 lollies. You take one this night and you take one tomorrow. 2 lollies for you, Ganiet. Next person.
You.
Next person. Remember, there were some 5-1 that I showed you. 5-1, remember?
Scrum.
Fantastic. Oh, Comfort. That's, let me just manage again. 2, I'll give you 2 again. 2 lollies. Fantastic. Next person who has
Kanban.
Kanban. Fantastic, Dorcas. Fantastic. Good. So now that takes us to, what are the phases? You know, we talked about waterfall. There were some phases out waterfall. There were things, all of them were coming together. What was those phases that we were explaining? Be mentioning them one after the other.
Requirements.
Fantastic, Debbie. What fantastic. 2 lollies. Next person.
Design.
Fantastic. Comfort, please. Don't let the lolly finish, please.
Development.
Debbie, please. Is development. Oh yeah, you want me to call names now?
Deployment.
I don't want to call. Evie, you said what?
Deployment.
Deployment. Fantastic. 2 lollies.
Maintenance.
Maintenance. Fantastic.
Testing.
Akiola, can you see that we forgot ourselves? 5 lollies for you, 5 lollies for remembering. So that is it. Who is that? Julius, who raised their hands up? Who have their hands up? Julius.
Yes, can you hear me?
I can hear you now. Sorry, I didn't hear you.
I said I raised it up earlier because I was going to ask you a question.
Okay. Yeah, no, you will ask a question. Yeah, let me quickly just ask my question, then I'll give you open the ground for you to ask question. So 1 minute, Julius, you'll ask your question immediately. Let me just test you people a bit. So again, so we have covered that. Who can remind me? There are 2 words that I was talking about, 2 faces. I call them twin.
Okay, verification and validation.
Emmanuel, too sweet. Again, fantastic. So verification. What did I say verification is?
One is expectation, like expected, and the other one is actual.
Which one? Which one? No.
Verification is the expected. And
validation
is the actual.
Correct. But I now said verification is like you checking that we are doing the right
product.
Now validation is that I am now looking, is it what the user exactly wants? Now me as a tester, I'm validating it. So sometimes you might be talking, if you want to make it your terminology, just make sure that you understand the concept. This twin that I'm telling you is the testing terminologies that I want you to be using all the time when we're talking, so that you say, oh, I'm doing verification and validation testing. People will say, oh no, this person is hot cake. That's what you're doing. I'm only checking the expected and actual. That's what you're doing. So I'm just trying to bring it to the easiest mode for you to understand. So those are the things. Then after then, we talked about V-model. I said V-model, give me some testing validation that connives with V-model. Give me some phases. From the verification phase, tell me, what do we do? And you verification, pick one of the user requirement. Fantastic. Who said that? Julius, fantastic. User requirement. Julius, tell me, what testing do we use to attack type of testing for user requirement? Can you remember? No. User requirements. Remember the testing plan that we use in the acceptance testing. Let's go back, guys. Let's go back. Let me go back to. Let me go back here. So this is it. I think, so I want you to see that. I don't want us to miss it. So look at it here. If you look at it, this is user as requirement. This is acceptance testing against it. So we've got the software application, we've got system testing against it. So this is what bet it. So now I'm going to go back to our screen so that so the next thing is let me see. Now let's go to STLC. What's the meaning?
The software testing life cycle.
Fantastic. Garniard, Doris, Comfort, 1 lolly extra. So if you software testing life cycle, there are phases that when we did the introduction to manual testing, I told you what are the processes that we use in defining that software life cycle, the software testing life cycle. Remind me.
Planning and control.
Correct. But it's called, Eldos process is called one name. Remind me of that name. Evie.
Fundamental test process.
Fantastic. That is it. So that's where we did the planning. So we now have some 6 levels. So let's start mentioning those 6 levels.
Gathering, test planning.
Fantastic. Julius, that's 5 suite for you. Nah. So
Building.
Design.
Design, test design,
Requirement.
environment setup.
Test execution.
Correct.
Test
Test
closure.
execution. Test closure.
Test cycle closure.
Thank you. Fantastic.
I can remember very well.
Test implementation and control.
Are they? Well done.
Let me get
You
to
ended up, so you are getting 2 lollies.
just check
So this is the process. So tomorrow we will start from the requirement gathering. I'll still give you an overview of what we have done today again, just a quick start, then we'll start tomorrow. So now the floor is open to your question. I'll take your question. We are beyond our time. So Julius, please, your question, please.
Yes. If I'm given a requirement, how would I know if the requirement is if I'm meant to write a test, how would I know if it's meant to be automation or manual?
Oh, fantastic. So the first thing you need to know, an automation candidate, manual, it depends on how you understand. Let me give you to you on a layman. When you want to automate, the reason for automation is that we use this thing every day, every time, every second. It's prone to error, but people use it all the time. So we want it to be easier for people to use it. Then, and to be quicker, then you need to automate it. But always remember, you cannot do a full 100% automation. Manual testing has to still be done to validate. So now you asked, how will you know? Take an example. If you let's take the rice that we want to boil. If you don't have water, you don't have pots. How do you want to boil the rice? You can't do it. So you must have something that you're going to use. The major key thing here that you need, that you'll be using all the time, is water. Water. You need that water. So you need to automate water. So you want to just open the tap to be finding the water there at any time. You need automation. Now let's take it to the software world. Take login, for example. You know there's no how you want to use an environment without logging in. What are you going to do? That's an automation candidate. You know when you enter an environment, there's no how, you have to search for something. That's an automation candidate. Do you get me? But having said all this, it depends on how the organization is. If it's automation, if it's manual, it depends. I can predominantly tell you that you might even be collected fund to tell you, oh, they will drill you so hard for an automation rule. But when you get there, you find out that it's manual testing. I'm in a place where I've advocated for automation testing so well for over 4 years. Unfortunately, I've looked at it, I've tried. In fact, I requested for experts to come in to see, but I know their native applications. They cannot. It is very difficult to be automated. Then, when I was asked to give my proposal to say why, I have to tell you, the first question I asked, how many people use this application? Who are they using it for? If it's not viable, if it's not used by everybody, there's no point wasting it to to do that. So those are things that we put into consideration when you are taking automation or manual. Julius, have I answered your question, or do you need any further?
But the amount you ask for,
Hmm?
what is
You said?
yes,
Hello, Julius.
Can
Eh?
you hear me?
I can hear you now.
I said there is high demand for computer tester.
Can someone please help me with what he said?
It's not very clear.
We can't hear him.
Okay. So we can't hear you, Julius. So while Julius comes back to us to ask us, who else have any question? Please, any question, please ask me. Unmute and ask.
I think my question goes like the same way you just asked. I just want to know, how do you know the test case to use?
How do you know the test case to use? So I'm going to explain to you how to know the test case to use. So, for example, when you're given a requirement, let's say a user story. In the user story, it says, as a user, who is a user? You need to know the actor. As a user, in order for me to enroll in Blue Sky, I want to be able to log in. That is a user story. So from this user story, can someone tell me, as a user, the user is anybody, anyone that wants to use Blue Sky, anyone that has access to Blue Sky. In order for me to be able to enroll for a course at Blue Sky, I want to be able to log in. I want to be able to access the login mechanism or login. What do you think I'm asking you to write the test case about? You can unmute and answer. Nobody.
Login.
Functionality.
Login.
Correct. So what we are trying to do here is that we are trying to log in. So it has already explained to me as a user, who am I? I'm the user. Don't forget, you as a tester, you are the user, you are the one representing the outside world. So you as a user, you want to be able to log in. So that is the story. Now in the story, they will give you acceptance criteria that login should have username, login should have password, login should the password should be 7 characteristics. So the first one is it must have a username. So your first test case should be on username. Your second test case will be password. Your second test case will be valid password. So you can see the way I'm already taking it. I'm still on that big user story, but I'm working on the acceptance criteria. That is how we design the script. Do you understand that, Debbie? Do you understand that, everyone?
Yes, it's more clearer now.
Yes, so that is the way. So now it might be, next one might be search. They might want you to set the functionality. In your acceptance criteria, ask, are there no acceptance criteria? If there's no acceptance criteria, now start bringing all search acceptance criteria. Who can help you? Go to Google. Tell him, search criteria. So you want to search. So you must be able to log in. When you log in, you want to search. So what are the items? You want to search and add it in the basket. So those are the things. That's how you're going to know what exactly you want to put together. So, yeah. Any other question? I hope you're clear now, Debbie.
Yes. Oh, yes. Thank you so much. That's more clearer.
Correct. You are still going to write test case. So don't think you all are still going to make it's going to be hands-on. You all give me your test cases. You are going to write it. People are going to watch. We are going to see what you are going to do. So it's this thing. It's still in this class. I'm going to teach you how to write it and how to import it to Azure DevOps. So that's the way it's going to go. So who else has a question? Julius, are you back to let us know what the question is? Any other question? Any question before we end the class?
Okay, please, Yemi, thank you so much for today's lectures. And my question is, like, in our various teams, we've got mentor, but like for you, is it for you just to lecture us? You don't have to do anything when it comes to the practical part. You only do the theoretical part. Or can we bring, because like presently in our team now, we are at the point of using this software testing lifecycle, because now we have the requirement. So we are waiting for the developer, to conclude on what the developer is doing, then we can pick it from there. So I believe it is this test planning, test design, the environment
Absolutely.
setup that will be doing.
Absolutely, Emmanuel. You are right.
So can we bring it here? Then you just, like I've never seen a test planning before. I've never seen a design before. So will you be showing that to us so that
Yeah, because okay, I'm going to show you. Oh, they shouldn't go there. Sorry. So I'm going to show you. Okay, let me start that way. You all are going to write a test plan, because I'm still going to teach you test plan. That's the chapter 6 of the textbook. The textbook has got 6 chapters. If you don't have it today, I'm going to speak to the admin. I will forward it again to her so that she can send it to you. But in the test plan is 6 chapters. I'm in chapter 2. So in this 6, the test management part of it is the very end. So that's why I'm going to teach you test planning, test strategy, the difference between them, how it's going to work, how you are going to design it, what it entails, what your expectation is. Then what I would do is that I will only give you a sample. I will show you. I will not give you the template. This is a template. If you design your own, I can tell you, most organizations, they do have a template. But if they don't have a template, like most of them don't always have automation template. I get there to give them my own template to say, embed this template if you want to do automation testing. Let's follow it. Let's put it in it. Even if you don't, add it as part of the. So those are the things that I put forward. But for us as a team, you are going to design it. I'm going to tell you, fine, you are already in that phase that you need to start designing it. I will start very soon. We are going to be moving to where we are going to be writing our script. So once we are there, it's going to still be chapter. Yeah. Is it Debbie that is talking? Can you please mute? So yes, so that's the way it is. So Emmanuel, we are going to, I'm just a mentor. Debbie, please just mute. So Emmanuel, I totally understand where you're coming from, but if you bring it here, if I do it, I can only, even if I give you a guide,
Where is this coming from?
We don't always allow it to.
Hello.
Hello? Yes, who is that?
It's Debbie.
Yes, no, because we're hearing some background noise.
Oh, sorry.
So that's why we said you should mute. So if that is it, then we can start using all this software testing lifecycle. So by tomorrow, we'll see where we get to, then you can start implementing it. But those mentors that you have there, they are meant to guide you. I'm here to lecture. Though I haven't said that, it doesn't matter that I still talk to people, of course, privately, but the mentors are there, they will help, and I'm willing and happy to help at any time. Just ping me. I'm willing and happy to help at any time.
Thank you.
So any other question before we end the class? In absence, Julius, are you back? Do you still need a clarification about the question? And if you want, you can ask. Evie, please don't forget, don't switch off your laptop, as Wumi has said. So once we finish, I'm sure she'll ping you to let you know. So, Julius, and everyone in the class today, I really thank you so much for your time tonight. So sorry we exceeded in time because we started late, but I want to say a very big thank you to you. And hopefully I will see you all again tomorrow. Have a wonderful night rest. We will recap again tomorrow. You've got lots of information here. Anything you don't remember or you need clarification, do not hesitate to get in touch with me. I wish you all the best. Have a wonderful night rest and a glorious tomorrow. Good night for now.
Yeah.
Thank you so much.
you.
Thank you.
Thank you.
Thank you.
Thank
you
you.
so
Good
much.
night.
Bye.
Yeah.